This tutorial demonstrates how to use Autodesk Civil 3D objects to build a basic corridor model. Note this tutorial uses the corridor assembly that you built in the creating an assembly exercise. A corridor can be used to model a variety of features such as highways, channels, and runways. In this tutorial, you will model a residential road. A corridor model builds on and uses various Autodesk Civil 3D objects and data, including subassemblies, assemblies, alignments, feature lines, surfaces, and profiles. Corridor objects are created along one or more horizontal baselines by placing a 2D section or assembly at incremental locations and creating matching slopes that reach a surface model at each incremental location. Let's start by opening up the Corridor-1A drawing in your Tutorials folder. Then go to your Home tab and then take a look at your Create Design panel. Next, click on the Corridor drop-down and select Corridor. In the Create Corridor dialog box, let's specify the following parameters. Alternatively, you can select these buttons to pick the objects from the drawing. Let's go ahead and name our corridor. We'll call it First Street. For baseline type, we're going to leave it at Alignment and Profile. Our alignment will be First Street, and we want to switch our profile surface to Finish Grade Centerline. For the assembly, let's select Primary Road Full Section. For target surface, we'll select Existing Grade. Now make sure that the checkbox for Set Baseline and Region Parameters is checked off. Then click OK. We'll open this up just a little bit more. Now that we're in the Baseline and Region Parameters dialog box, go ahead to the RG-Primary Road row and specify the following end station within the cell. Then press Enter. Next, let's select the frequency by pressing this button. And within the Frequency to Apply Assemblies dialog box, under Along Curves, we want to make sure that the value is set to @increment. Now for the curve increment, we're going to specify 3. Go ahead and select OK, and select OK again. Now we have a notification that the corridor definition has been modified and needs to be rebuilt. What would you like to do? Note, if the task dialog box is not displayed, the corridor is still built. But in this instance, we want to rebuild the corridor. As you can see, our corridor is now built along our center line. So that's how you go about creating a basic corridor model in Civil 3D. In this exercise, you'll create a corridor assembly with transitions. So let's go about creating an assembly baseline. Go ahead and open up your Corridor-2A drawing in your Tutorials folder. Next, go to your Home tab, and then to your Create Design panel, and then select the drop-down for Assembly. Select Create Assembly, and then we get a Create Assembly dialog box. We're going to give it a name of Transition, and we're going to leave all of the rest of the defaults alone. Go ahead and click OK. When the Specify Assembly Baseline Location prompt is displayed on the command line, go ahead and click a point in the drawing to place the assembly. I'm going to place it right over here. The viewport zooms to the assembly baseline, which looks like this. So let's go about adding a lane subassembly. Let's go ahead and open up our tool palette, and then make sure we're in the Civil Imperial Subassemblies palette. The way to go about making sure is to right click on the control bar, and we can select it right here. Now make sure you're on the Basic tab, and then select Basic Lane Transition. Under the Advanced portion of our properties, make sure that we're on the right side, and for the default width we're going to specify 14 feet. For a depth we're going to specify 1 foot, and for transition we're going to change offset and elevation. In the drawing, click the marker point on the assembly baseline. Now you'll see a lane is drawn, extending it 14 feet to the right with a slope of -2% and a depth of 1 foot. Let's add a curb and gutter to this subassembly. In the tool palette, select Basic Curb and Gutter, and then go back to our Advanced properties and make sure that we're on the right side, and with a gutter width of 1.25 feet. In the drawing, select the top right edge of the lane to draw the curb and gutter. Now let's add a sidewalk subassembly. In the tool palette, select Basic Sidewalk. Next, go into your properties. This is going to be on the right side again, with a buffer width of 2 feet, and for another buffer width of 3 feet. In the drawing, go ahead and select the back of curb. Now let's add a ditch subassembly. In the tool palette, select this subassembly. Next, go into your properties, and under Advanced we have a lot of options here. But first we're going to start off with the side. We're going to leave it at right, and we're going to keep things simple. We're going to specify a 3-on-1 slope. In the drawing, go ahead and click the outside marker. In the tool palette, go ahead and select Basic Lane Transition. And then under Advanced, we're going to choose a side of left with a default width of 12 feet and with a depth of 1 foot. For the transition, we're going to hold grade and change offset. In the drawing, we're going to select our marker point on this side of the assembly baseline. A lane is drawn extending 12 feet to the left with a slope of -2% and a depth of 1 foot. Now let's mirror the subassemblies outside the right lane. Go ahead and press Escape to exit the subassembly placement mode. In the drawing on the right hand side of the assembly, make sure you select the curb, the sidewalk, and the daylight subassemblies. Right-click and select Mirror. Now, select the marker point at the top left edge of our transition lane. Now you can see that the subassemblies are displayed on the left side of the assembly marker. The mirror command creates a mirror image of the selected subassemblies. All the subassembly parameters except for the side parameter are retained. Now note that the parameters of the mirrored subassemblies are not dynamically linked. If you change a parameter value for a subassembly on one side of the assembly baseline, the change will not be applied to the opposite side. So that's how you go about creating an assembly with a transition lane in Civil 3D. In this exercise, you'll create a corridor using the assembly created in the last exercise. You'll target the width and elevation of the right lane edge to a right alignment and profile, and the left lane edge to a polyline and a feature line. This exercise continues from creating an assembly with a transition lane. So let's specify the basic corridor information. Note, this exercise uses the corridor-2A drawing from the previous exercise. Or you can also open the corridor-2B drawing in your tutorials folder. So let's start by going to your Home tab and then to your Create Design panel. Next, click on the Corridor drop-down and select Corridor. In the Create Corridor dialog box, specify the following parameters. We're going to give it a brand new name, and we're going to call it Corridor-Transition Lanes. Then for the baseline type, we're going to leave it at Alignment and Profile. And then for the alignment, we're going to leave it at Centerline. For the profile, we'll switch that to Layout. And for assembly, we're going to specify Transition. The transition assembly includes the basic lane transition subassembly, which uses the transition parameter to specify that both the offset and elevation can change on the right side of the corridor. The offset can change on the left side of the corridor, but the grade is held at -2%. Now for the target surface, we're going to specify that as the existing grade. And make sure the set baseline and region parameters is checked. After that, go ahead and click OK. Now we're going to specify the fixed lane horizontal target. In the baseline and region parameters dialog box, we're going to set all targets. Now we're in the target mapping dialog box. Specify the following parameters. In the transition alignment row, for the right side, we're going to specify an object name. The object type that we're going to target is alignments, and we want to select the right alignment. Go ahead and click Add, and then click OK. In the transitional alignment row for the left side, we're going to do the same thing. We're going to click the object name, but we're going to specify a different object type to target. We're going to select feature lines, survey figures, and polylines. Next, go ahead and select from drawing. And we're going to select this blue feature line and this magenta feature line that's on the left side of the alignment. Go ahead and press Enter. Notice that the entities are added to our table. Let's go ahead and click OK. Notice that because the subassembly names contain the assembly side, it's easy to determine which assembly must target which offset object. This naming convention is even more useful in road designs that contain many alignments and subassemblies. For information on updating the subassembly naming template, see Modifying the Subassembly Name Template exercise. Now let's specify the fixed lane elevation targets. Now within the transition profile row for the right side, let's select object name. We're going to leave the target on profiles. For the alignment, we're going to switch that to the right side. And for the profiles, we're going to specify the layout profile. Go ahead and click Add, and then click OK. The right side pavement edge elevation is set to the Layout 1 profile. The left side edge of pavement elevation does not need to be set since its elevation is determined by the grading setting. Now we're going to press OK twice. We do want to rebuild our corridor. The corridor model is now built and looks like this. So that's how you go about creating a corridor with a transition lane in Civil 3D. In this exercise, you'll create a fairly complex assembly with a depressed median and separate lanes. So let's go about creating an assembly baseline. Go ahead and open up your Corridor-3A drawing, which is located in your Tutorials folder. Next, go to your Home tab, and then to your Create Design panel. Click the Assembly drop-down, and select Create Assembly. We get our Create Assembly dialog box. We're going to go ahead and give it a name. Call it Divided Highway, and then click OK. Now we're being prompted in the command line to specify assembly baseline location. Go ahead and click anywhere within the drawing to set this baseline. You'll see that the viewport zooms to the assembly baseline, which looks like this. So let's go ahead and add a median subassembly. If the tool palette containing the subassemblies is not visible, go ahead and go up to your Home tab, and then within Palettes, click this icon right here. Within the tool palette, right-click on the control bar and make sure that you have Civil Imperial Subassemblies checked. After that, click on the Medians tab. Go over to this subassembly, Median Depressed Shoulder Extension. And what I want you to do is right-click on this and then select Help. In here you can review the diagram to better understand the subassembly. Now go ahead and click on the subassembly. In the Properties palette under Advanced, we're going to change a few things. Under Centerline Pivot, change this to Pivot About Centerline. After that, we're going to keep our median widths the same. In the drawing, go ahead and click on the marker. You can see that we now have a depressed median and the inside shoulders drawn. Next, we'll add a lane subassembly. In the drawing, pan to the left edge of the median depressed shoulder extension subassembly. Zoom in so that you can see the marker right here. Go ahead and click the Lanes tab and select Lane Super Elevation AOR. This subassembly inserts a travel lane that follows the slope for the super elevation properties of the alignment. In the properties, go ahead and go into your advanced area. For the side, we're going to change this from right to left. And for the width, we're going to assign it 24 feet. Now in the drawing, go ahead and select this marker point. And when we zoom out, we see how it fits together nicely. Now we're going to add a shoulder subassembly. In the drawing, pan to the left side of the last assembly that you just inserted. And in the tool palette, click the Shoulders tab and select Shoulder Extend Subbase. Go over to your Properties panel, and under Advanced, we're going to change a few things here as well. We're going to keep it on the left side, but for Use Super Elevation Slope, we're going to change this to left outside shoulder. And everything else, we're going to leave it at its defaults. This sets these slopes to the outside shoulder super elevation slope. In the drawing, select this marker right here, which is the marker point at the top outside edge of lane on the finish grade to add the paved shoulder. We can go ahead and zoom out and pan around. Go ahead and press Enter again to exit that out of the command. Now we're going to add a daylight subassembly. In the drawing, we're going to zoom into this area right here. Now click the Daylight tab. Now right-click on the Daylight Standards subassembly and click Help. Go ahead and review this diagram and behavior section to better understand the cut and fill daylighting behaviors. In the tool palette, go ahead and select Daylight Standard. In the drawing, go ahead and click the marker at the outside edge of the shoulder extend subbase subassembly to add the daylight slopes for cut and fill. And you can see how that looks. Lastly, we're going to mirror the subassemblies to the right side of the baseline. Press Escape to exit the subassembly placement mode. In the drawing, we're going to zoom out a bit. I'm going to turn off my tool palettes here so we can see the entire thing. I'll go ahead and select the daylight, the shoulder, and the lane subassemblies. Then right-click and select Mirror. Zoom in to the right side and click the marker point at the top edge of the median subassembly to draw the mirror of everything else. Go ahead and zoom out, and you can see how everything appeared very nicely. Now the mirror command creates a mirror image of the selected subassemblies. All the subassembly parameters are maintained except for the side parameter. Also note that the parameters of the mirrored subassemblies are not dynamically linked. If you change a parameter value for a subassembly on one side of the assembly baseline, the change will not be applied to the opposite side. So that's how you go about creating a divided highway assembly in Civil 3D. In this exercise, you'll create a divided highway corridor. This exercise continues from creating a divided highway assembly. So let's go about creating a divided highway corridor. Note that this exercise can use the corridor-3A drawing from the previous exercise, or you can open up the corridor-3B drawing from the tutorials folder. Let's start by going to the Home tab, and then over to the Create Design panel. Next, click on the Corridor drop-down and select Corridor. We get the Create Corridor dialog box. Let's go ahead and give it a name. We'll call it Divided Highway. We'll keep everything at its defaults except for the profile. We're going to change this to our layout. And then for the assembly, we're going to choose the divided highway that we just created. For the target surface, we're going to select the existing grade. And then for the set baseline and region parameters, we're going to clear this box. When the set baseline and region parameters box is cleared, the default corridor creation settings are applied to the corridor. Go ahead and click OK. You'll see that the corridor model is now built, and it looks something like this. So that's how you go about creating a divided highway corridor in Civil 3D. In this exercise, you'll view how a corridor assembly is assembled at various stations along a baseline alignment. The View Edit Corridor section tools are useful for inspecting how the corridor assemblies interact with other objects in the corridor model. So let's go ahead and view a corridor section. Go ahead and open up your Corridor-4A drawing, which is located in your Tutorials folder. The drawing contains an assembly, as you can see right here, a profile view, and a corridor model. Each object is displayed in a separate viewport. The viewport that contains the assembly is now active. We'll start by clicking on the corridor. Then go into the Modify Corridor Sections panel and select Section Editor. On the Section Editor tab, go ahead and select a station by clicking this drop-down and going to the very first station, 0. You'll see that a cross-section of the corridor at the starting station is displayed. The elevations and offsets are displayed on the grid axes. The cross-section view contains the assembly as well as the other adjacent objects. At the current station, the offset alignments are represented by a vertical green line, as you can see right here. And the existing surface is represented by the horizontal red line. The vertical red line at the center of the grid represents the assembly baseline. Profile intersections with the baseline are indicated with this little marker right here, this magenta circle. You can use the tools within the Section Editor tab to view the corridor sections at each corridor station. Go ahead and click forwards. And backwards. You'll notice that as I click, you'll see a line showing where we are currently within our section. In fact, let's highlight this viewport and we'll go into our corridor, and you can see this line here as well. So continue to move through the section and you can see both lines move along with each station. Let's experiment with the zoom modes. Go ahead and zoom in to the lane on the right side of the assembly. Then go ahead and select this button to go to the next station within the assembly. Notice that the view zooms back out to the grid extents. There are 3 zoom modes in the View Edit Corridor section tools. These modes control the behavior of the grid when you navigate to another station. In the Select Station list, go ahead and navigate to Station 3. Then within the Zoom Tools panel, go ahead and click this drop down and select Zoom to Subassembly. Now we have the Pick Subassembly dialog box. Go ahead and select this drop down and select Daylight Right and click OK. The view zooms in to the Daylight Right subassembly at Station 3. Notice the shape, elevation, and offset of the subassembly. Go ahead and go back to the station list and go down to Station 9. The view zooms in to the Daylight Right subassembly at Station 9. Notice that the shape, elevation, and offset of the subassembly. It's quite different from Station 3. The subassembly remains at the center of the grid and at the same zoom factor as you navigate to other stations. Go ahead and go back to your View Tools panel and select this drop down again. Then select Zoom to an offset and elevation. Then click Go to the next station a few times. Notice that the offset and elevation values that are displayed on the grid do not change. The shape of the Daylight and Right subassembly changes to reflect how it ties into the existing ground surface. Lastly, go ahead and select Zoom to Extents. Then select Go to the next station. You'll see that the view backs out to the extents of the assembly. So that's how you go about viewing corridor sections in Civil 3D. In this exercise, you'll edit the parameters at several corridor sections. You'll edit a section in 2 ways. First, you'll modify a subassembly parameter at a single station, which will override the subassembly settings for that station only. Second, you'll modify a subassembly parameter and then apply the modification to a range of stations. This exercise continues from viewing corridor sections. So let's go ahead and modify subassembly properties for a single station. Note that this exercise uses the Corridor-4A drawing from the previous exercise. We'll start off by panning over to our corridor in our top view and then going over to our Modify Corridor Sections panel. Select Section Editor and then we get our grid. Go ahead and navigate to Station 7, 75. Next, within the Zoom to, we're going to zoom to a subassembly, and we're going to select lane right. Then click OK. Once we get this view, go ahead and select Parameter Editor. Then pops up our editor. We'll move this off to the side. Within the Corridor Parameters dialog box, we have our Assembly-1 tree, and then we have several groups. If we collapse these down, we can see things a little bit better. What we want to focus on is lane right. Go ahead and expand that. You'll notice that identical values show up within these two columns, the design value and the value column. The design value column displays the value that was specified when the subassembly was added to the assembly. The value column displays the actual value of the subassembly at the current station. In the following steps, you'll override the design value at the current station and then examine the results. Go ahead and scroll down until you get to the width value. It's currently set to 12. We're going to change it to 36. Then press Enter. Notice that the Override checkbox is now set to True, which indicates that the design value has been overridden at this station. Go ahead and go forward a few stations and watch this particular area right here that we just changed. You'll notice that it goes back to 12 feet. So the lane subassembly that's displayed in the section view updates in width to reflect the width at the current station. Let's go back to 775. See how we're right back to 36. What we'll do is we'll go ahead and click this checkbox and clear it so it's back to false and we're back to 12 feet. Now we'll modify subassembly properties for a range of stations. Go ahead and go into your View Tools panel and then click this drop down and select Zoom to Extents. Next, within the Select a Station panel, click the drop down and select Station 450. Notice that the road is in a shallow cut on one side and a deep cut on the other. The criteria set for the daylight subassembly caused it to use a certain slope on the left and a certain slope for the right. Also notice the super elevation transition of the road. At station 450, the lanes are relatively flat. Go ahead and go into your station selection and select 775. Notice the super elevation transition. Using the centerline pivot option on a depressed median subassembly causes the lanes and the shoulders to super elevate about a point above the centerline ditch. A straight edge laid against the lane surfaces would pass through the profile grade point. Go ahead and select the parameter editor. Under Assembly 1, go ahead and expand the median, and you'll see the centerline pivot. You can see under the design value and the value itself, you have one that says pivot about a center line. What we're going to do is we're going to select within the value column and select pivot about an inside edge of road of traveled way. On the Corridor Edit Tools panel, select Apply to a Station Range. In the Apply to a Range of Stations dialog box, notice that the start station is at 775, which is the current station. For the end station, enter in 11. Then click OK. Now, go back in the Corridor Edit Tools panel, then select Update Corridor. Now go ahead and go from station 775 up to 11. And you can see how the centerline pivot override is currently checked. You can see how it's still checked off. Now we're at 11. Now if I select the next station, you'll see it uncheck. There we go. We'll go all the way to 1175, and you'll see that this override check is cleared. So that's how you go about editing corridor sections in Civil 3D.